Hello, everybody. My name is Emmitt Muckles. I am the sales engineer manager for Tigo here with our director of training, which is Mr. Greg Smith. Today, we're going to talk about power. Everybody knows about batteries, which is very prevalent in this day and age in solar, but they don't always understand the concept of energy versus power. So I'm going to jump right into it. Power is energy that is consumed or generated per unit of time. Understand that. Power is energy that is consumed or generated per unit of time. For instance, I have this battery that you might not be able to see clearly, but it clearly states it is a 3,000 milliamp hour battery, and the voltage is 3.7 volts, which actually equates to being a 3 amp battery at 3.7 volts. What that means is 3.7 volts over an hour can supply 3 amps of current. Now, if I have a load on here, that can change that time that power is delivered. So I'm going to kick this over to Greg, because Greg is much more efficient at explaining this because he's the book battery guy.
Yes, yeah, and that's people that bought the book and commented to me, like were surprised that I started with basic terms and definitions, and I even make fun of myself, right, in that way. But we forget, because we're these old farts in the industry. We've been around. We forget, like, these people coming in, they don't know, right? And so the reason I wanted to do this power connection was because in the last, I don't know, 7 to 10 days, I got 3 people through, either email or on our community asking about it. Like, what's the difference? Even like on my book website, they said, what is the difference between that? So there's something going on, so we have to talk about it. Right? And so you touched on power as this energy per unit of time. And I'm just a big, car guy. I like to use cars in these analogies, right? So when I think of power, I think of power as like the speed of your car, right? And energy and power are 2 totally different things. And people confuse them all the time. Like, how many times have you had somebody say, "Oh yeah, hey dude, I just installed a 20 kilowatt battery." Wow, man, that's some big load, right? What they really meant to say was a 20 kilowatt. They were talking about the capacity.
Or they're talking about the amp hours, or 20 kilowatt hour battery. And these terms, because of this little letter, can get really confused and throw people off. Yeah. And like Greg was saying, it's analogous to a car, the speed of a car. I may have a car that has 400 horsepower, but if it's just sitting there, that tells you kind of the measure. It's not till you start moving over time that you can really measure what this is going to do. And exactly. All this is in watts, kilowatts, all that stuff.
Yeah, and so just using that one term by itself doesn't mean anything, right? Like, for example, if you were to say, "Hey, Greg, let's go meet up at this place and let's eat some freaking barbecue and drink some adult beverages. When are you going to get here?" And I said, "Oh yeah, dude, I'll be there at 75 miles an hour." That doesn't mean anything, right? And so you need this other component, right? And people do use them interchangeably, almost as bad as they use module versus panel, but that's a different discussion. But if we use power as speed, then energy is the capacity to do work, right? If you think way back to your high school classes, and work can be anything. Like, we were talking this morning about how you did yoga. That's work, more work than I can do, but it's that work over time component that we need, right? And so most people may kind of understand what power is, because, as you said earlier, power in electrical terminology is measured in watts, right? And watts is a volt times an amp. And so people see the W on the light bulb and they say, okay, they kind of get it, right? But energy is different. But I guarantee you, everybody has probably seen the unit of measurement for energy, kilowatt hour, on your utility bill. Most people don't know what it is, right? But they know how much they pay a month.
So help me. Let me see if I explain this right, Greg. And you be the purveyor. So I have a one. Let's pitch this as a 1 liter bottle, and then I can pour it out. I can pour out the whole liter at one time. It depends on, and it's leaking. I can pour out the whole thing at once, but the rate is what we're talking about. So we have the measurement, but then we have the rate things are depleted from it. And that's what we're talking about, energy versus power.
Yeah. And you know what? And I got sidetracked by myself. So power is speed, energy is distance. Yeah. And so now when you say, when are you going to be here? I can say, well, it's 75 miles away. I'm doing 75 miles an hour. I'll be there in 1 hour. Yeah. And so let's flip that into something more relatable, into what we're actually trying to talk
That's
about.
actually a good one, man, because if you go down to 35 miles an hour, you'll be there in about 2.
Exactly. So now let's convert that, right? So let's say well, for example, and I'll put a short video clip in here to show you. My toaster oven over here pulls 1,400 watts. Okay, like it's beefy, right? So at 350 degrees, it pulls 1,400 watts, right? So let's say it takes me 20 minutes, right, to heat up a whole play of dino nuggets, right? I love those. You can tell I have kids. And so what we would need to find out is 1,400 watts for 20 minutes. Yeah, and so that's a third of a kilowatt hour, or in time, rather, the time. And so we take 1,400, multiply that out, and we get 466 watt hours. Like, okay, but I don't get it. Right? So that would be 0.466, and I'll put this on the screen. That would be 0.466 kilowatt hours, and that is what your utility charges you for. They don't charge you for the power that you can. They don't charge you the 1,400 watts. I'm charged by how long I use the 1,400 watts. So if it's 0.466 kilowatt hours and my utility rate is 14 cents a kilowatt hour, well, it just cost me 6.5 cents to cook those dino nuggets. Well worth it, by the way. But now, let's have you give a more relatable example when it comes to battery capacity.
So, and this is a really common one. As you said, most batteries range somewhere in 5 to 10 kilowatts, physical kilowatts. But the kilowatt hours may be larger than that because it's over time. What people get confused is that over time, they think that's what the value or what the storage of the battery is. You literally have to look at the battery itself, but then you have to look at the loads that are going to be put on it so that you can know what amount of time. This is going to be really prevalent as we move to this new dynamic with electric cars. Everything is always on. You're getting a battery backup system for your home. You have to calculate circuits. So you have to know, okay, it's going to pull this amount of energy over this amount of time. This battery says it can supply this for as a standard. How does that relate? That's when you start looking at the calculations that Greg was talking about. And we do these sheets that literally tell you, hey, you have this many loads. If they all came on, you have this amount of time that you can actually use it. For some people, it may be more time. Some people, it may be less time. For instance, if you're trying to charge a Tesla, no, don't do that. Off of your battery, it's going to go like that. Versus if you're trying to charge your cell phone, it may be weeks before it depletes that single battery.
Yep, absolutely. And that's the hardest part of this whole thing, right? Because when you talk about capacity in your power, the $1 million question for a new homeowner, how long will this battery bank last? Right? The real answer is 2 words, right? And I always joke around about it, but it's true. It depends. It depends on the factors that you said, right? Depends on how many loads you have on, right? That is power. But what matters more is how long you run the loads. And so if you run 1,000-watt load for an hour, that's 1 kilowatt hour. If you have a 10 kilowatt hour battery, then you get 10 hours. Dude, if you're in the middle, like for example, here in California, PG&E turns off the power at will, right? When the wind gets above 35 miles an hour, bam, this area, no power. And I recall very specifically, and I talk about this in the very first page of my book. I had to change the names because, you never want to tell on anybody. But there's people that when PG&E turned the power out and they had a battery system, they thought it was a good idea on the second day to have a hot tub party.
No.
And I'm serious. And a hot tub pulls 6,000 watts. If you have a 240 heater, 6,000. So how long is that going to give you if you got a 10 kilowatt hour battery? Nothing, right? 10 kilowatt hours divided by 6 kilowatts, you're just below 2 hours, right? And that's it. And that's if you only have the hot tub on. So the biggest part of our job now that Tigo is in the storage business now with our EI solution is managing these customer expectations.
So we're going to end on this. You and I have this wonderful saying. Someone randomly comes up to us and says, hey, I just got a battery system. How long is it going to last? And our statement is, it depends. Come to our community, tigoenergy.com. You can find a wealth of information there. You can find our community. So if you have questions, we are there to answer them. Greg and I monitor as well as the rest of our team. We have some great products that are available for you. And we have a bunch of information that we usually pull from to give people a nice centered piece of intelligence when they're doing their installation. With that, have an awesome day and enjoy the moment.
See ya. Take care.